So you've definitely heard about Bitcoin, Ethereum, and this whole crazy world of crypto. But what's the actual tech that makes it all tick? Well, in this explainer, we're going to pull back the curtain on blockchain, the engine that powers the entire thing. How does a system with no boss, no one in charge, actually work? It really all starts with one huge question.
Just think about that for a second. When you send money online right now, a bank or a company like PayPal is the referee. They say what's real. But in the crypto world, there is no central boss. So what stops someone from just spending the same digital dollar twice? This is the fundamental problem that blockchain was built to solve.
Okay, so to really get this, we're going to go on a little journey. We'll start with the main idea, a shared digital notebook. Then we'll follow a transaction through the network, see how everyone agrees on the truth without a ref, and look at code that literally runs itself. After that, we'll zoom out to see its real-world impact and, super important, its trade-offs.
All right, let's dive in. Section 1, the shared digital notebook. Let's just start with the absolute core concept here. For a minute, forget all the crazy jargon. At its heart, you can think of a blockchain as just a very, very special kind of shared digital notebook.
So, on the left, you've got the old school model. A bank holds the one master copy of the ledger. If their server goes down while everything grinds to a halt, it's a single point of failure. But on the right, with blockchain, it's a totally different game. Everybody on the network gets their own identical copy. It's distributed, which means no central weak spot, and no single person is in charge.
And this simple idea of a shared notebook, it unlocks three incredible features. First, like we just said, it's distributed. The data lives everywhere on tons of computers. Second, it's immutable. Once a transaction is written down in this notebook, it's basically sealed in digital cement. You can't just go back and change it. And third, it's transparent. On public blockchains, anyone can pop the hood and verify the records for themselves.
Okay, Section 2, the transaction's big journey. So we've got the big idea down. But how does this thing actually work moment to moment? Let's follow one single transaction and see what its journey through the network really looks like.
So let's keep it really simple. Imagine you want to send $10 worth of crypto to your friend. You type it in, you hit send. So what happens next?
It's basically a five-step dance. First, you create and digitally sign the request. This is like your unique, unforgeable signature. Step 2, that request gets broadcast out to all the computers. They're called nodes on the network. 3, these nodes check to make sure you actually have the money to send. 4, once it's validated, your transaction gets bundled together with a bunch of others into a new block. And finally, the magic part. That new block is confirmed and cryptographically chained to the one before it, which makes it permanent.
So how does it become permanent? It's through something called hashing. Just think of a hash as a unique digital fingerprint for all the data in a block. And here's why that's so incredibly secure. If you tried to go back and change even a single comma in an old transaction, the digital fingerprint for that block would completely change. And that would break the link to the next block, which would break the link to the next one, and so on, creating this cascade of broken links. The whole network would see the tampering instantly. It's what makes the chain so tamper-proof.
Up next, Section 3, how everyone agrees. Okay, this is a big one. We've got thousands of computers, right? And they all have a copy of the notebook. But with nobody in charge, how on earth do they all agree on which new block of transactions gets to be added to the chain?
The answer is something called the consensus mechanism. That sounds complicated, but it's not. It's just the rulebook. It's the set of rules the whole network follows to agree on what's true, making sure everyone's copy of that digital notebook stays perfectly in sync.
Now, the two most famous rulebooks are proof of work and proof of stake. With proof of work, which is what Bitcoin uses, computers called miners all compete to solve this ridiculously hard math puzzle. The first one to crack it gets to add the next block and earns a reward. It's basically a race of pure computing power. On the other hand, you have proof of stake, which Ethereum uses. Here, validators put up their own coins as collateral. They stake them. Then, the network chooses one of them to create the next block. It's a system based on having skin in the game, not just raw power. And it's way more energy efficient.
All right, Section 4, code that runs itself. You see, just securing transactions was only the beginning. The next huge leap for blockchain was making it programmable. And this is where we get to the really game-changing idea of smart contracts.
So what is a smart contract? It's pretty much just a program that lives on the blockchain. And honestly, the best way to think about it is like a digital vending machine. You put in the right coin, which is the data, and the machine automatically spits out your snack, the outcome. No cashier, no middleman needed. The code just follows the rules of the agreement automatically once the conditions are met.
And the possibilities here, they're just massive. Imagine you could automate a payment to a supplier the very second a shipping container's GPS confirms it arrived. Smart contracts are also the engine behind NFTs, proving you own that piece of digital art. They can run entire financial exchanges without any central company. And they can even be used to create brand new cryptocurrencies from scratch.
So, as you can see, this programmability takes us way beyond just digital money. Let's look at Section 5, Blockchain's real-world impact, and see how this tech is already starting to shake things up in other industries.
Think about supply chains, for example. Blockchain can create a perfect, unchangeable record of a product's journey, proving your coffee is actually fair trade. Or how about digital identity, where it could finally give you control over your own personal data instead of big companies? People are exploring it for everything from secure voting systems to sharing medical records to even proving that you are the true owner of that rare magical sword in your favorite video game.
All right, Section 6, the big trade-offs. Now, as cool and powerful as this all sounds, this technology is not some magic bullet. It's really important to have a balanced view and understand that it comes with its own set of challenges and limitations.
The strengths are pretty clear, right? You get incredibly high security, totally transparent records, and no single person or company in control. But there are always trade-offs. These systems can be a lot slower than, say, Visa's network. Proof-of-work systems use a ton of energy. And, let's be honest, the whole thing can be pretty complex for a beginner to get their head around.
So, when you boil it all down, what's the key takeaway? At its core, blockchain is just a fundamentally new way to build trust and verify information online. It's that secure, shared digital ledger that makes crypto possible, but its real potential to spark new technologies across countless industries is really just getting started.
So, in the end, blockchain is a system for creating trust between people who don't know each other, and it does it with code instead of a middleman. So, I'll leave you with this to chew on. When you look at the world around you, what's one industry you think needs that kind of automated trust the most?